Hi, my name is TJ Fini, and today I'll be talking about the use, safety, and mechanism of action of Hanna Instruments Iron Colorimeter. In this presentation, I will cover the why, what, and how of this instrument. That is, why this tool can be useful for your project, what we can do to stay safe while using it, as well as how we can use it. First, let's talk about why this tool can be useful for your project. This specific tool is a digital iron colorimeter designed to measure total iron, both iron 2 and iron 3, in water samples. Its range is from 0 to 5 ppm or parts per million, and its accuracy is plus or minus 0.04 parts per million. Quick disclaimer, throughout this presentation, I'm going to use mussels as an example as a filter feeder for a lot of the time because this is the organism I use for my project. This information should apply to all filter feeders, not just mussels. However, you should also do research on your end about the specifics of your model organism. Filter feeders are essential keystone species for the figure organisms because, as seen in Figure 2, they remove amounts of particles within the water column, excrete nutrients back into the water column, and provide nutrients for primary producers. A lot of these particles are potentially hazardous, especially heavy metals. This can be seen in Figure 3 as mussels are able to filter out heavy metals such as copper, nickel, and zinc. Unfortunately, many of these heavy metals are too expensive and or too dangerous for us to use in our lab, so we must find alternatives. Iron is a great alternative because it is both cheap and relatively safe, and it's also a heavy metal. Thus, by analyzing how filter feeders filtrate iron, we can draw conclusions as to how they would filtrate other heavy metals. However, before we get into the details of how to use this device, we must also address safety. Unfortunately, this instrument requires the use of Hi721 reagent, which is potentially hazardous. It is dangerous if swallowed, exposed to your eyes, or disposed of improperly. It also releases toxic gas if exposed to acids. In order to mitigate these hazards, we must wear penetration-resistant work gloves, lab aprons, proper footwear, as well as safety goggles. A type P filtering face mask should also be used. Please take caution when disposing of this substance because it can harm the environment. Now that we know how to stay safe, we can learn about the use of this instrument. Turn the meter on by pressing the button. All segments will be displayed. When the display shows add, see I with press blinking, the meter is ready. Fill the cuvette with 10 milliliters of unreacted sample and replace the cap. Place the cuvette onto the meter and close the meter's cap. Press the button. When the display shows add with C2 and press blinking, the meter is zeroed. Remove the cuvette from the meter and unscrew the cap. Add the content of 1 packet of the HI reagent. Replace the cap and shake gently for 2 minutes until the powder is completely dissolved. Place the cuvette back into the meter. Press and hold the button until the timer is displayed in the LCD, or alternatively wait for 3 minutes and press the button. The instrument directly displays the concentration of iron in ppm. The meter automatically turns off after 2 minutes. If this process didn't work for you, here's some troubleshooting you can do. If the water sample is too turbid, it might need to be pre-filtered. Reagents need to be fully dissolved, so continue to shake or use the Voltexer for assistance. Check the dates on the reagent. If it's old or expired, the readings will not be accurate. Here's some tips as well as some directions for cleaning and maintenance. For tips, test within the temperature range of this device. Also avoid air bubbles, dirt, or unfiltered particles. For cleaning and maintenance, rinse cuvettes thoroughly after each use and air dry. Clean the lens inside the meter periodically using a soft cloth or lens wipe. Check cuvettes to ensure no scratches or stains. As you can see, I first filled the tube with unreacted water. I then zeroed the device by placing the unreacted sample in. Once the device is zeroed, I then took the tube out and placed the reagent powder in, before putting the sample back into the device and pressing and holding the button. This then starts a 3-minute analysis to measure the iron concentration. Judges may ask you about the mechanism of action of this device, so it is important to understand the chemical reactions that take place when using this device. First, the HI reagent reduces iron 3 to iron 2 by adding an electron. Then iron 2 reacts with the 1,2-phenethylene in this reagent, which reacts with iron ions, which produces a product, which is red-orange in color. The more iron 2 ions there are in a solution, the more of this red-orange product is produced, and therefore the more red-orange color the solution becomes. After these chemical reactions take place that cause the solution to become colored, the tube is placed back into the device, where it is exposed to incident light. This enables the device to analyze the light spectrum emitted by the solution. In particular, the device detects the absorbance value of 510 nanometers, which correlates to the red-orange color. This absorbance value is then used to compute the iron concentration of the sample, as the more red-orange there is, the more iron there is. This is known as the phenanthally method. This entire process is based upon the Beer-Lambert law, or commonly known as Beer's law. Here are the sources that I used for this presentation. Thank you for watching.